Hey, let's walk through how to use Uber Orbit, which is their time series forecasting tool. We're using it for marketing mix modeling. It's not specifically what it's for, although it's one of the use cases it supports. So we're going to follow along with this tutorial, and this is very high quality. I really enjoy this guy's content. Called Mario Filo from Kaggle Grandmaster. Really interesting approach that he has here. I'm just going to kind of walk you through it. I've replicated what he did using the data, but I've also added a couple of things as well. So first thing we need to do is install the libraries. One thing you can do in Google Colab notebooks, and you can make a copy of this, is you can do percentage pip, and that kind of lets you run the pip commands like pip install or ml to the actual kernel of this computer that this is kind of hosted on. So first you install, if I just press shift and enter here, first you install Orbit ML, and then there's also Nevergrad, which I use for budget optimization. It's the same one that Facebook Robin uses. And then we're also doing this fix. This might have been fixed by the time you try this tutorial, but essentially I found that there was some error where if we didn't use this specific version of matplotlib, then it would break. So you can see here that it's installed everything. You just want to hit restart runtime and click yes, so it can use those libraries. And you can see here it says initializing, so that means, there we go. So now we've got the library, we've got the runtime, and it should work. Okay, cool. So first thing we want to do after that is import the different libraries we're using. So we're using Orbit models KTR. This is the time varying model, the one that we're most interested in, where the coefficients can change over time. And you'll see pretty quickly what that means. So we're going to hit here to authorize. If you haven't authorized your Google account, this is going to pop up with a log into your Google account prompt, and then you just authenticate. And then this is going to let you pull the data from the spreadsheet. So what I've done is I've used the same data that he points out here. I'm just going to click through to his other tutorial where he gets the data from Kaggle. So I just downloaded the data set and unpacked it. One thing I did find is that the raw data has some errors in the dates. So this was like something I ran into. Let me see if I can find the example. Oh, here we go. Yeah, so see some of the data in this format instead of in this format. So it's important to fix those. I fix them manually. So if you look at my data set, that's all clean. There's none of those issues. So that's the one that I've linked to here, and this is open, for you to use as well. Cool. Okay, so what this code does is when you're authenticated, it looks at this spreadsheet and then pulls in and then shows the data set, as you can see here. One thing we need to do, I found, is convert the date column to a date time format. And then this is just telling it what format is it in right now, which is the shortened month, the percentage B, the date, and then the year after a comma. Cool. So now let's look at this. You can see that the spend and sales are objects. They should be floats. And the reason why they're like that is they have dollar signs and commas in them. So this is something else I had to do that wasn't mentioned in the tutorial. Quite often you have to do data cleaning. So I just have taken those columns and then just applied these functions to remove the dollar sign, and then applied the same function but using the comma here to replace the comma, and then I converted it into a float. And you can see now the data types of floats instead of objects. Cool. So now that's done, I'm going to run this code here, which is from his tutorial again. What it does is kind of group the data and kind of pivot it, unstack it. So now it's in this format, which is the format we're going to use for the actual marketing mix modeling. And This is where we're setting up the marketing mix modeling. So we're kind of taking the different columns that we're using. We're using sales, the regressor columns. This is the X variables. These are the marketing campaigns that you can see. We're choosing a split point of 28 days. So it splits at the end of the data. And that's the holdout group. That's going to be how we predict future data, right? So that the model hasn't seen. So we're going to hold back the last 28 days. And then the model is going to try and predict that after training on the rest of the data. And if it can predict that 28 days hasn't seen, then it should be able to predict the next 28 days for you as well. Cool. So we have the split point here, which is kind of splitting it into the train and the test data sets. And then we have to scale the data. So this is pretty common for any machine learning or data science. You have to scale the data so it's all, you don't have like some variables that are like in the thousands and some variables are in the tens. What this does is it divides by the highest absolute value. So don't worry too much about this. This is how it works. This is fit transform thing here. And then we have a different scalar for the y variable. So all the x variables are the same, and then we have the y variable, which is different. Okay, so this is actually, so I'm going to just run that. And each time I'm pressing just like shift and enter to run it, but you could also hit play here. And then this is the actual model. So I'm going to run this model, and then I'm going to talk about what it's doing. So we're feeding it the response column, the data column, date column, the regressors. We can actually incorporate this, which will hurt the accuracy, but it will make sure that we don't have any negative coefficients. So that might be worth doing, or at least worth testing if, for example, you expect that your marketing spend is never going to drive negative sales. So that's quite useful. We also have here the seasonality. So this is like how many, like what the pattern is. We do 7-day pattern here because we have daily data. So this is kind of a weekly trend. You could also do, if you had weekly data, you could put a 52 here. But you'd have to have at least 52 weeks in the training data set. Then we have an estimator, and then this is related to the Bayesian estimation stuff. So we're going to fit the data, and then you get the prediction. This runs pretty quickly in my experience, and just already finished there. Cool. So once we have the estimator, then we can just plot the regression coefficients. And this is the money shot. This is what we're here to see. So what it's showing is for each one of our channels, how do the coefficients change over time? So the blue line in the middle is the coefficient that we normally get. The blue, kind of light blue shaded area is the uncertainty. So you can see it's quite, fairly wide range here. And then you can see that it changes over time. So some coefficients are pretty stable. Other coefficients like change over time. This one's kind of started low and then go high and then down again. So this one's had started with more uncertainty, ended with less. So you can see some interesting patterns here. And typically what you're going to see is some channels are more stable than others. Cool. So that's the really interesting thing about this library as the time varying coefficients. It means that when you do a normal marketing mix model, the assumption is actually that the coefficient would be the same for all time periods, which isn't true. Isn't likely to be true. You worked hard on improving your marketing over time, right? You're optimizing. You shouldn't expect your marketing to perform the same as it did last year. Might actually perform worse, if because of COVID or something like that. So this is a really great way of dealing with that. Cool. So now that that's run, we just need to set up this media data full data frame, and that's how we're gonna work out the contribution. So that's basically just taking the scalar and kind of getting the values that we're basically multiplying the coefficients over time by the inputs over time, and then we're going to get the total contribution of each channel, and we can plot that here. So this is how many sales drove. We have some channels here, like ad group 1, brand 2, ad group 1. that drove like a lot of sales. We have some that are negative, which is, unlikely, right? Like these are all marketing channels, so we wouldn't expect them to be negative. If we wanted to rerun this, we actually could. I'm going to do that maybe at the end, just so you see the difference. But for now, let's just see how this model works. So if we look at ROI and then plot ROI, we can see that like a lot of them have no ROI, right, because they're negative, and then some have a lot of ROI, which is maybe a sign that the model hasn't gotten it correct. I would look a little bit more into this if this was something I was presenting to a client, because they're probably not going to believe that one ad group drove like 400 ROI, $400 for every dollar invested, and some drove zero or negative. Cool. So the next thing we're going to do is optimize the media budget. So I'm not going to go too much into this because it's covered elsewhere, but this is using basically creating an optimization function to shift the budget around within limits, and then we're using Nevergrand here to actually kind of do that recommendation. So you just pass it this optimization function, and then it should give you, here we go, yeah. So this is how much you should spend in each one of the channels. So this channel you should spend 3,000, this channel 212. I'm not going to go deep into that. This is something that it's not specific to Uber Orbit. This is using Nevergrad, which is what Facebook uses to optimize budget. And Uber Orbit doesn't provide its own, which is why we covered that. Why you covered that in the tutorial. Cool. So a few other things they didn't cover in the tutorial. One thing which I think is interesting is seeing the trend line over time. So because this is kind of a time series prediction library, it has like something which is kind of cool. It shows what the trend was. This is the underlying kind of organic trend absent all the marketing spend. And you can see it's actually pretty stable, like flat over time, but the uncertainty is getting bigger and bigger. So that is maybe an indication that we're not capturing everything in our marketing mix model. We've got different levels of spend, etc. But maybe we've caused some. Maybe we have, like, if we have kind of increasing uncertainty over time, that's a pattern that we don't want to see. Maybe there's something we can improve the model, like we're missing a variable we want to add in. Cool. So the other one is the actual kind of regression. So this is everything like separate from the trend. So that's the underlying trend, and then this is the impact of the marketing spend. Cool. So the other thing that I wanted to add in here was plot the predicted data. I just think this looks really good. It's like a great way to see how accurate you think how accurate you think the model is, and it just kind of shows the data over time and then what the prediction is for the future. You could also overlay on here. I didn't get a chance to, but you could overlay on here what the actuals were. That kind of tells you like what it thinks. Like if you were actually predicting, if you didn't have the actuals and you were predicting what sales are going to be next month, then you could use that, to predict that. And then you could kind of then try different scenarios and say, hey, what if we doubled our marketing spend? Where would we get to, and how much uncertainty is there around that? Cool. So the final thing we want to do, you can see this is still scaled. So it's between 1.4 and 0. So it's not a real number, right? It's not the real sales number. So we have to unscale it, and we want to get the actual kind of percentage error. So we want to see how accurate this is. So Uber uses SMAPE, which is like symmetric mean absolute percentage error. Facebook uses MAPE, which is just normal mean absolute percentage error. But the way, we don't have to worry about how that's implemented. They provide that function, SMAPE function that we imported earlier. But what we do need to do is unscale the predictions. So we take our scalar y, and then we do inverse transform, and we pass in the predicted values and reshape them so they're in the right format. Then we'll get back the unscaled prediction, and then we just need the actuals. So we're going to take the raw media data, we're going to split it by the split point to get the test data only, and just the response column, so just sales, and then values and reshape, same thing again. And then if we just pass those both into SMAPE, then we get 13%. So on average, on a given day, this model is incorrect by about 13%. And I would say below 10% for MAPE is really good. So this model is like pretty good for where it's at. And you can make directional decisions based off it. Okay, hopefully that's helpful.